Hello everyone and welcome. Today we'll be architecting full stack solutions in a Jamstack world. Lots to talk about, let's dig right in. My name is Joel Varty. You can follow me on Twitter at Joel Varty. I'm a father of teens, high school football coach, a lover of musical theater, and a lifelong developer. I'm also president and CTO at Agility CMS. Most important slide today, you are a developer, your voice matters, ask questions, ask the hard questions. It's okay to ask weird stuff. We're on a journey together, but it's your job to help explain things to people, things like, software architectures and patterns, full stack and Jamstack, all those concepts. Let's dig in a little bit on those and help you sort of talk about those. We're going to talk about two kinds of solutions today. We have apps, we have APIs. Apps is anything with a UI, static websites included. Basically, anything can run JavaScript these days. So it could be a website, it could be a mobile app, it could be a smart TV app. If you can run JavaScript, you can build an app with it. You can also build an API. An API is anything that exposes data. It can perform actions on that data, it can manipulate the data, or it can call other APIs. I would say it's an API-driven world now. We're just living in it, right? Full stack means worrying about everything all at the same time. We have to worry about the apps, we have to worry about the APIs as part of an architecture that goes together, right? And usually we think of development as two kinds of development. We have front-end development and back-end development. A lot of us kind of identify with one of those two concepts, or maybe we think of ourselves as, as one or the other. JavaScript that runs in the browser is kind of a full front-end type of a thing. CSS, HTML, visual design people tend to be front-end people. People who build up design systems, that's more of a front-end kind of a concept, right? Whereas back-end is like server code, databases, caching. If you're the kind of person that's into system architectures, that tends to be something that's considered a back-end kind of a concept, a multi-tier system that's also a back-end concept. Well, full stack, it means you have to care about both things, especially in terms of architecture. So for monolith, they would combine both the front end and the back end into one application, which is a really bad idea that doesn't make anybody feel good, right? So as a full stack kind of architect or developer, we need to sort of decide where the code is going to go. And understanding where your code is running is top priority in this. It's going to either run in the browser, could be running on a server, it could be running as part of a build process. The key here, check your console.log statements. If you have a console log statement that ends up in your browser, code's running in the browser. Servers have build logs. Build servers have their own logs as well. You got to find those statements. Make sure that you understand where your code is running. Sometimes it runs in more than one place, which can be really confusing. Jamstack, it kind of plays mind games with us because it gives us frameworks like React, which is Gatsby is built on top of, that we think of as a front-end framework. React runs in the browser, so does Vue and Svelte and these other things. However, we also have tools that are like static site generators, and some of them now they're starting to be called hybrid frameworks because they can run code kind of anywhere, especially in terms of React. React running on a server seems weird, but it does happen with Gatsby. But then we have serverless functions, which also run JavaScript, which is part of Jamstack, right? Could be, this kind of the idea of this started with AWS Lambda, but now we have Azure functions and Google has ways to run these. And what really cooks my noodle is the idea of Netlify and Vercel functions, which are super easy to build, really easy to provision and get out there. And they're just serverless functions that can do whatever we want them to do in terms of calling APIs. And we'll look at the patterns that involve these kind of things. All right, so Gatsby itself, sort of what is it? It's a static site generator. So when we're generating code for a static site, that code runs at build time. It has preview mode, so that's kind of like a server-side rendering because it does it dynamically as we need it to show us what's in preview. It has incremental build, right? So that's part of the Gatsby sort of open source concept. The easiest way to run all that, obviously, is with Gatsby Cloud. So point Gatsby Cloud at your Git repo, and it does all these things for you. You could also roll your own, right? Because when Gatsby Cloud runs, it runs sort of on the edge inside Gatsby's own place, with the sort of in terms of where that code is going to run physically, right? So if you need it to run in a specific spot, you can have your own build server, your own DevOps process, or a Docker container that has this that runs it inside whatever cloud environment you need it to be in. It could be in a local on-prem environment too, right? Let's follow the flow of our code as it works its way from the repo to the UI, right? So we check in our code merge a PR. Somehow that code lands in the main branch, and then it's going to trigger something, which is basically npm run build or yarn build. At that point, we're going to be pulling in any kind of the build time APIs that we need to call. Typically, they're things like headless CMS and e-commerce. So those are things that we need to build together for SEO to generate that static site. It could be other stuff as well. In Gatsby, we call those source plugins, right? That is going to generate a static site. We can think of that kind of like a browser app, because it really is. It's now a React app in terms of Gatsby that's going to run in the browser. Well, what's very similar to that is a mobile app. Okay, so a mobile app is something we build. It doesn't really matter about SEO, but in terms of it's got all the static stuff that it needs to basically execute that app, and then it's running on a mobile device. Now, those things basically have the ability to call serverless APIs. So we can write serverless functions that can call any of these APIs that generate the functionality that we need, things like authentication, databases, messaging, data processing, or any other API. So all that functionality, think of that as serverless. So we're going to call it from a serverless function. Some of these services have actual browser-based APIs and some of them don't. But if we think of them as a serverless sort of concept outside of the build process, then it helps us sort of place them where they need to be. And there's tons of services that have sort of sprung up that are really work well on the edge. I'm going to dig in specifically to databases because that's one of the ones where it comes up a lot. We almost always need to persist data somewhere. And how would we do that? What's the best way to sort of handle that? So I'm going to take three different concepts. One is Fauna, which is kind of a new school. It's database as a service. It's globally distributed. It's really meant for serverless kind of functions like this. Fauna is a great service. Then we have Azure SQL Server, or just SQL Server itself, which is pretty old school, right? It's a database server. It's a real attack vector. Lots of folks have really sensitive data in their SQL Server databases. They need to put it behind firewalls, and it has very specific sort of authentication stuff. It's designed to be in an intranet. Amazon Neptune is a little different. It's cloud scalable. It's a little more flexible than something like SQL Server, but it's still an attack vector. It's still really, and even though it's designed to be hyper scalable, it's living in AWS, and we want to sort of consider it that way. All right. So for Fauna, we can easily call Fauna from a Vercel or Netlify function. No problem. It's a service that's designed for that. Azure SQL Server, we probably want to call that from something like an Azure function itself. All right. And same with Amazon Neptune. We probably want to call that from an AWS Lambda function or from any compute that runs inside AWS itself, right? The reason for this is all about how it was built. Fauna was built to work with basically anybody. It works really great with Netlify and Vercel because those are edge kind of systems that don't rely on anything in terms of specific cloud resources. Azure SQL Server, it can be called by Azure resources much more securely because it can run on the same sort of intranet inside Azure Cloud. Similarly, AWS, we can set up that kind of resource there as well, right? So we think of Fauna as great, and all those services that are sort of built for edge as great for edge to edge, right? And all the other stuff that's sort of internal to those cloud networks, we need to call those with resource affinity. We need to be close to them so that they're more secure and faster. All right, let's just look at a few different architecture patterns specifically for Jamstack and Gatsby. All right, so we have what I call static plus edge. So somehow you've got a Gatsby website sitting out there. It's a statically generated site. We're going to call it from Vercel or Netlify functions and other APIs. Why do I recommend Vercel and Netlify? Because they're free and really easy to get started with. But then we also have Gatsby Cloud, which I also highly recommend for folks because it's really easy to get the Gatsby side of things all built. Right? So we can also call Vercel or Netlify functions from there, and then of course any other API that we can call from those serverless functions. The more specific one that I'll spend a little bit more time on, I call it Docker plus cloud. It could be any kind of sort of compute that runs, but we're going to basically have Gatsby self-hosted in Azure or AWS, or it could be on-prem as well, and it's going to call the internal resources for that. All right, let's dig into these patterns. Static website, somehow you generated your static Gatsby website, right? Some people actually build it locally on their own machines and send it up to the cloud. It could be any way that it got built. That's going to basically call serverless functions using browser fetch. Okay, so the browser is actually going to be calling and invoking a function. That function itself can call all the APIs in the world, anything that it needs to do, authentication, database messaging, we talked about it before. E-commerce is another one we never really talked about yet. UGC, search, sort of anything that it needs to do that's kind of back-endy, I call it, anything where it needs to do stuff, right? That's going to be a server-to-server call. So the browser invokes a serverless function. The serverless function then goes and calls that other service, right? Any static website can do this. Those functions can be deployed separately. They don't need to be part of your Gatsby project. And you can use I would, in this case, use serverless optimized APIs for these. You probably don't want to be calling your SQL Server direct from a serverless function in Netlify or Vercel. Okay. If we're using Gatsby Cloud, it's slightly different, right? Because we're going to check in our source repo, and Gatsby Cloud is going to pick that up, do the build plus the incremental, and generate a static website. And Gatsby can push that website to a bunch of different places, right? So it's going to be hosted somewhere, it's static hosted, but our browser is going to do the exact same thing, right? Same as we had before. It's going to call a serverless function. That serverless function is going to call server fetch to do all those other APIs that we had, same thing. Basically exact same architecture, except it was Gatsby Cloud doing the work. And it's important to understand that, because where does Gatsby Cloud run? They're hosted on the cloud. It's an edge type service. So if you needed to call stuff as part of the build time, sort of at build time, those should be edge optimized APIs, okay? If they're not, right? If it's not optimized for that, then you're looking at something where you probably want to be self-hosting Gatsby, okay? And this gets a little more complicated, and it's a little more to consider, right? So say we have a Docker container that, somehow our code is on the Docker container. We can call npm run build or npm start to actually get that going, to sort of serve those files. There's a bunch of different ways we could do that, right? That has now generated our website that we're invoking statically. It's still a static website, right? But it built inside Azure and AWS. The browser fetch that we're calling there is actually not inside, right? Our browsers are not running inside the cloud, but they can call the serverless functions that have resource affinity to all those cloud specific services that we may or may not need. All kinds of stuff can be, and Azure and AWS and Google have like a gazillion sort of cloud services that are there. Some of them are better at being edge optimized than others, okay? But if you have specific stuff that needs to be called with resource affinity from the build and or from the serverless function, you can do that there. All right, so you can run Gatsby and Docker, you can deploy the functions separately, and the functions are going to have a close affinity to those cloud resources, okay? Now, those are just 3 different architectures. There's lots of different ways to mix and match those, but I think that kind of answers a few of the questions about sort of how do I do this specific thing? I often get, how do I do login with a Jamstack site? How do I do database stuff or, Redis caching, things like that? We can answer those questions if we think of the separation of where the code will run and how a serverless function can help us and how we're going to get our build to happen. Right? There's a specific example that I talk about a lot. It's headless commerce, right? So those are things like, Shopify, Stripe, BigCommerce. These are sort of, services that have come about that have headless commerce APIs. So we can get our products, we can do checkout with these services. A lot of folks that I've talked to have actually built these themselves that are running inside, AWS or Azure. So they're not really edge optimized. So that's why the examples I showed earlier are really important. But when you think of it, we've got build time. So if we're in Gatsby Cloud, it's going to be, at build time, it's going to pull in the products that it needs to output. It's going to combine those with, content from the CMS. Anything that requires SEO, we're going to optimize, right? We're going to have that built as part of the static website. And then at runtime, we're going to do things like, log in and have the person register or whatever. We're going to do checkout things. We're going to add to cart. We're going to do the payment. Right? So the runtime serverless functions help with all that. So for instance, if we were using something like Stripe for our payments, well, we don't want to put our Stripe secret inside our browser, right? That's not a good idea at all. We want to hide that secret behind a serverless function and have that on a server that runs, okay? And this is just sort of some of the things to think about in terms of when you're doing commerce, what API you choose and how it sort of works is going to have a build time and a runtime implication to talk about, okay? So I hope, it was a very quick session. We've had just a little bit of time to learn about our full stack architectures, and we've got a few different patterns that I've showed to you today. I want to continue the conversation though. You can follow me on Twitter at Joel Varty or at AgilityCMS. Agility has lots of events that we run for training as well and just sort of talking about Jamstack. So agilitycms.com/events is a good place to check those out. Or you can email me, joel@agilitycms.com. It's been great talking to you. Enjoy the rest of GatsbyConf.